Okay. Good morning. Today we are going to see the lecture number 23, capacitor start induction motor. Okay. Capacitor start induction motor. It is one of the second type of starting methods in single phase induction motor. Capacitor start induction motor. The basic introduction. You see the picture. What it denotes, what it means. These are the passive components, right? It's a capacitors. It will be in different rating. Okay, this big one, it will be 100 microfarad. So based upon the specification, the size of the capacitors will be decided. And this is a capacitor, this is a motor capacitor which will be used in the motor. Okay, it will be used in the motor, because since the motor will be operated, we are operating AC motors, right? This motor operating for almost 0 to 220 or 400 volt also. So the capacitors which we are using in the motor, it's almost 330 volt AC. Okay, 330 volt AC. The size of the capacitor, it is very big size. Okay, it is very huge size we are using in the machines. And this is a pictorial representation of your motor, that is nothing but capacitor start induction motor. So we have to place the capacitor at the top layer of your motor. Okay, I am not disturbing any type of constructional arrangement inside the motor. I am just using a capacitor at the top layer of the motor. Okay, why? Because the capacitor, it is only used for starting purpose. Okay, the capacitor is only used for starting purpose. Okay, what is meant by capacitor start motor? A capacitor start motor, it is a single phase induction motor that employs a capacitor in the auxiliary winding. What is meant by auxiliary winding? Can anyone tell me what is another name of auxiliary winding? What is
Starting winding.
starting winding? Good. The another name of auxiliary winding is, it is a starting winding, which produce a greater phase difference between the current in the main and auxiliary winding. Okay, the definition of capacitor start motor: it is a single phase induction motor that employs a capacitor in the starting winding or auxiliary winding, which produces a greater phase difference between a current in main and auxiliary winding. A greater phase difference means it is almost greater than 30 degree. Okay, that is nothing but greater phase difference between the current in main and auxiliary winding. Okay, so the name itself, the capacitor name itself show the motor which uses a capacitor. Okay, so what is the purpose of this capacitor in this motor? That is only for starting purpose. Okay, it is one more question. Okay, the motor uses a capacitor only for the purpose of starting. Okay, only for the purpose of starting. Okay, so this, you can see this picture. Okay, this capacitor, it is available in the market, which is only used for the machines. Okay, in the nameplate detail itself, they will mention this capacitor will be operated for AC. Okay, now we will explain the basic concept of capacitor. Okay. We know the Okay, we know the two types of elements are there. One is active element in electrical engineering. Another one is passive elements. Active elements means it will be a voltage source, voltage source, current source are called active elements. Only sources are called active elements. That is input and output are called active elements. Passive elements means whatever the components which will be connected inside in your circuit, that is nothing but passive elements. That is resistor or inductor, capacitor. Okay, resistance means the symbol, it will be look like this. It is a resistor. Okay, V equal to I R. So therefore R equal to V by I as per the Ohm's law. The resistance is the property which opposes the flow of current. The resistance is a property which opposes the flow of current. Okay, inductance is the property. Okay, inductance means it will be look like this. Okay, it is L. So if you apply the voltage, V equal to L into di by dt. Many times I informed, okay, the lecture, the ongoing lecture is recording. Okay, please be on time. After the class, I will call that particular students. I know those people, 3 people, I will call them. The inductance is a property which stores energy in the magnetic field. Energy in magnetic field. Okay, which stores energy in the magnetic field. So in the machine, inside in the stator there are windings are there. Okay, here only the inductor is available, inductor and resistor which is available. Okay, but what happens to the capacitor? Capacitor means it is a parallel plates. Okay, there are two parallel plates which will be placed between a dielectric medium. Okay, this is nothing but a dielectric medium. Okay, dielectric medium. If we apply the voltage, we can get V equal to 1 by C integral of I dt, because capacitance is a property which stores energy in electric field, in electric field. Okay, so you see the formula V equal to 1 by C integral of I dt. Okay, so this lower limit and upper limit will be there in integration. This lower limit for discharging, upper limit for charging, upper limit for charging. Okay, but when you see the capacitor in our motor, the size of the capacitor, it is very large. The reason is that, okay, because it will be operating the motor, right? There are big windings are there. So based upon this winding arrangement, current, voltage, everything, because we are operating through single phase line. Okay, so because of the single phase line, the size of the capacitor is very large. By using C equal to the formula epsilon A by D. Okay, if the size of the capacitor, okay, if the value of the capacitor is increases, the area of the capacitor is also be increases, but the diameter will be decreases. This is my diameter, it will be decreases, but my area, it is be increasing it. Okay, this epsilon is the dielectric medium. Epsilon is equal to epsilon naught into epsilon r. Okay, so this is the basic concept of capacitor. Okay, this capacitor only we are going to use in our motor. Okay, what type of capacitor? It is the AC type capacitor, AC capacitor. Okay, in the market, if we ask motor capacitors, means they will give this one capacitor, just we will insert it. Okay, we'll insert it. And in this, because the capacitors are different types, one is parallel pit capacitor, electrolytic capacitors are available in the market. Okay, in our AC machine we are using, it is the AC capacitor. It is the AC capacitor. Okay. It is a AC capacitor which we are using in our AC machine. Okay, then it will be called as motor capacitor also, because we are operating through AC. It is a motor capacitor, and the name of the capacitor type, it is, the type is electrolytic capacitor. Okay, electrolytic capacitor. Okay, so this is a capacitor which we are using in our motor. Okay, electrolytic capacitor. In your objective type question in the quiz last, okay, which capacitor will be used in starter and motor, means immediately you had write electrolytic capacitor. It is a dry type, electrolytic capacitor. Okay, dry type electrolytic capacitor. And another one which we are using here in this capacitors, we are having a centrifugal switch. Okay, we are using the centrifugal switch. Okay, a definition of the centrifugal switch, which is, it is the electric switch that operates an electrical centrifugal force created from the rotating shaft. It is mostly used in electric motor. Okay, so this switch will be operated, okay, which will be designed to activate activate or deactivate deactivate has a function of rotational speed of the motor. Speed of the motor. Okay, since centrifugal switch, it is nothing but it is a electric switch. Okay, it is a electric switch, because we are using in motor, right? Motor will convert electrical energy into mechanical energy. Since we are converting electrical into mechanical, so we have to say the centrifugal switch called electric switch. Suppose if the same switch will be used in generator, the generator will convert mechanical energy into electrical energy. That is, we have, at that time we have to say it is a mechanical switch. Okay, since the switch will be used in the motor, we have to call it as centrifugal switch, which is the electrical switch which using only a centrifugal force created from the rotational shaft. Okay, you see this picture here. Okay, so in this picture, okay, this is a switch. Okay, this is a switch. Okay, this switch will be connected in the mounted on the shaft. Okay, mounted on the shaft. It is just automatic switches. It is having the contact. It is the automatic switches. Okay, now circuit. This is a circuit for our capacitor start induction motor. We are giving here, this is positive, negative, single phase supply, 230 volt, 50 hertz, 50 hertz AC, single phase AC, 230 volt. I'm giving it, and there are two windings are there. One is main winding, another one is starting winding. Okay, main winding, another one is starting winding. This both the windings having a same dimension and number of turns also. Here number of turns is 4. Here also it is 4. You see here 1, 2, 3, 4. Okay, here also 1, 2, 3, 4. So 4 number of windings. Okay, 4 turns are available. Okay, this both the windings are connected in parallel. Okay, are connected. This is my junction point, are connected in parallel. Now we have to take a electrolytic capacitor. This electrolytic capacitor, it's only connected in series. Okay, we have to take an electrolytic capacitor, the notation is C. This capacitor which is connected in series, okay, which is connected in series with starting winding, okay, which is connected in series with starting winding. In the series connection, you know, in series the voltage is different, current is same. Okay, the current is same. Since we are operating a single phase current of 7.5 ampere, which is getting to the parallel part and it is equally distributed. So the current flows in the starting winding, the notation is IST. Okay, IST. The current flows in the main winding, the notation is IM. Okay, the notation is IM. This both the currents, okay, the current IM which lacks the voltage. Okay, the current IM which is the current IM which lacks the voltage. Okay, the current IM lacks the V. Okay, lacks the voltage by an angle phi m. Okay, the current flows in starting winding IST leads the voltage by phi st. Okay, phi st. We know the property resistance, it is only applicable for unity power factor. Inductance means it is applicable for lagging power factor. Capacitance means which is applicable for leading power factor. Leading. Since we are using the capacitor in the starting winding, so the capacitor is available in the starting winding in series connection. So the IST current which is leads the voltage by phi st. But here in main winding there is no capacitor, so it is an inductive property, it's only lagging it. Okay, or you know the difference? The IM current lags voltage by an angle phi m. IST leads voltage by phi st. This is a basic difference. Okay, and at the end of the capacitor I am connecting a centrifugal switch and it is connected to the motor. This is my circuit. Now the operation. Now if we apply the voltage, okay, if we apply the voltage to this starting winding and main winding, what happened? The flux is produced. Okay, the flux is produced. Flux is produced. Okay, both flux are produced. Then the centrifugal switch, here it is there, right? You have to close the switch. Okay, you have to close the switch. Once you close the switch, the current in the starting winding which will energize the capacitor, which will charge the capacitor, then the machine start running it. Okay, once the capacitor will charge, immediately the machine will start running it slowly. Okay, now you have to vary this supply from 0 to 230. Once you set 0 to 230, within a second we have to release the switch. Okay, you have to open a switch. Once you open the switch, the capacitor will be discharged, which will discharge. Okay, which will discharge and it will be removed. Discharge means it will be removed from the supply and the starting winding also be removed. Capacitor and starting, both the parts will be removed. Now by using this main winding, the machine continue to run. Okay, so when your centrifugal switch is closed, when this your centrifugal switch is closed, at that time the capacitor is charging. Once the capacitor charge, then your starting winding will start the motor to run slowly. Start the motor to run slowly by using a low voltage. Okay. Now if you vary the voltage to 230, then what happened? You have to open a centrifugal switch. Once you open it, the capacitor will be discharged, which is discharged. Then your starting winding will be disconnected, which is disconnected. So by using main winding, this main winding, which makes the motor, to run continuously, Okay, so when the motor is running continuously, at that time the starting winding you should not use, capacitor also you should not have, because your centrifugal switch is open. Okay, centrifugal switch is open. Are you understand? Okay, so this is the operation of capacitor start induction motor. Okay, capacitor start induction motor. These are the steps, just now I explained it. Okay, and here if any high voltage will come, okay, or high current will come and the switch is closed, the capacitor will be burnt. Okay, so we have to match the rating of the motor with our capacitor rating also. Okay, we should be very careful, Okay, and the phasor difference between a main and auxiliary current will be increased. Okay, if it will be increased, both the currents are increasing it, then we can increase the starting torque also. Okay, these are the steps. And now when the speed of the motor which achieves 75 to 80 percentage of synchronous speed, then the starting winding should be disconnected. Okay, then the starting winding should be disconnected. Okay, if it is disconnected, the centrifugal switch we have to open. Okay, we have to open the centrifugal switch. So what is the main purpose of this capacitor? The capacitor which is only used for starting purpose. Okay, for running purpose we have to use only main winding. Are you understand my point? Whether the operation is understandable? Any doubts? Harshan, Harsha or Harshan, I don't know that name. Any doubts? Any doubts? Okay. Now phasor diagram. You see this phasor diagram. Okay. How to draw this phasor diagram means, first take scale pencil, you put 0 and draw a straight line, fix voltage, it is 230 volt. Okay, now starting current, it will be, I already mentioned, the starting current will be leading it. Okay, this is my rated current, the starting current with is IST. Okay, what is the starting current value? Starting current means lagging or leading? Can anyone tell me? Starting current is lagging or leading? Anyone?
Leading.
Leading. Okay, good. Starting current is leading it. It is leading it. So the angle between from V to IST, it is 5 ST. Okay, 5 ST. Okay, the angle between the current to IST, which is alpha. not alpha, it is okay, it is phi m. Okay, the angle between ist to I, it is also alpha. Then the im current, it is very high compared to starting current, so the angle between ist to vi I can extend to alpha. Okay, I can make it as common notation called alpha. The angle between v to im, which is phi m. Okay, now you have to join these points. Okay, this is the phasor diagram. Okay, it is one of the 3-mark question in your internal examination, as well as in the objective type also. I will mention this diagram. I will ask you to identify the what is the angle between ist to im. ist to im, it is alpha. ist to im, which is alpha. Alpha is an angle between ist, starting current, and main current, starting winding and main winding. Okay. Okay, so here the current im, which is lags the voltage by an angle of im, but ist, which is leading it. Okay, lags means it will be goes in negative quadrant, leading means which is going in positive quadrant. Okay, positive quadrant. So how much a large phasor difference means, the large phasor difference which is almost greater than 60, that is, it is almost comes around a 90 degree. Okay, the starting torque is proportional to alpha. This is torque speed characteristics. Zero. Okay, now the machine, now you are operating centrifugal switch. Okay, you see this diagram, you will understand it. In x-axis it is speed, y-axis will be a torque. Y-axis torque, x-axis speed. At zero there will be a centrifugal switch is closed. In this point at zero, centrifugal switch is closed. During that time we are having a low starting torque. We are getting a low starting torque because when a centrifugal switch is closed, at that time both the main winding and auxiliary winding we are operating it. Now we have to vary the voltage. The lower starting torque will be slightly increasing it based upon our speed. Okay, this is nothing but synchronous speed 1430 rpm as per the machine data. Okay, now once the speed is achieved, now what happened, because the motor is start running it. Now once that speed is achieved, immediately you have to open the switch. Okay, this point will be a centrifugal switch is open. Once centrifugal switch is open, you should not operate by starting winding. We have to operate only by the main winding. Okay, only by main winding. There is no capacitor, there is no starting winding. So by using the main winding, we are getting a starting torque from 0 to a maximum position. Okay, this maximum position we are getting, which is very full load torque. This is the full load torque. Okay, so the curve is also be a non-linear curve. It is not a linear, it is a non-linear curve which almost starting from 0, slightly increasing, and it shall reach a maximum, then it will be decreasing it to reach the ns point. Okay, when you compare this both the curve, okay, this curve is somewhat visible, and this curve there will be a slight disturbances are there in the curve. When we operate the motor in the lab, we can get a disturbances. Okay, we can get disturbances. Now please note down the electrolytic capacitor range I am operating here. It is 250 microfarad to 500 microfarad. Okay, rating. Okay, and this VAR stands for volt ampere reactive. VAR stands for volt ampere reactive, because in our circuit we are having both the inductor and the capacitor. Okay, inductor and capacitor. You see, this is my inductor, capacitor. This both are in parallel. Okay, both are in parallel, and here also one more inductor will be there. This is for starting winding. Okay, since all these parameters are available, so we will get the volt ampere reactive. Okay, it is apparent power. Advantages. The main advantage here, we are getting very high starting torque, and we can use it for very high starting loads. These motors have high starting torque up to 300% of full load torque. But the power factor value is very low at rated load and rated speed. This is the advantage. Disadvantages. This type of motor is available up to 6 kilowatt. Okay, up to 6 kilowatt. Applications. It's mainly applicable for high inertia loads. High inertia means high starting loads. So therefore, the frequent starting is required, which is mainly used in pumps and compressors, refrigerator, air conditioner compressors, and conveyor and machine tools. Machine tool means the CNC machines. They are operating it. Okay, refrigerator, air conditioners, pumps and compressors. Okay, in your examination, I'll ask the question. Okay, elaborate the concept of starting method of single phase induction motor which is used in air conditioner compressor. Okay, again I will repeat the question. Elaborate the concept of single phase induction motor used in air conditioner compressor. If I mention this word, immediately you have to write capacitor start induction motor, draw the diagram, neatly explain the operation, draw the start speed characteristics, phasor diagram. That's all. Okay, I understand. And this motor, they are operating with high loads, right? So based upon the high load, the capacity, that is nothing but specification of the capacitor, is also be identified. Okay, we have to take care of the capacitor also, because the capacitors are very dangerous part. Okay, if any high current or high voltage we can operate it greater than the rated specification of the capacitor, automatically the capacitor will be blast. It will be accident. So we should be taken care. Okay, immediately it will be blast. Okay, that's what most of the accidents will be happening in our domestic appliances. You can see the newspapers. Okay, the person is watching the that is he is using the air conditioner during night time. Because of the air conditioner blast, he passed away. Like that you are getting, because they are having the compressors there in the air conditioners. They are having a large type of capacitors. Okay, since that person he's not make that air conditioner in the proper servicing, because we have to keep the air conditioner in the proper servicing mode. Okay, as well as safe mode also. Otherwise, when high current or high voltage entering into our air conditioner, you will get a spark. Okay, and finally it will be blast. So we should be taken care of. Any doubts? Okay, thank you.